Welcome to the today's video lecture series. In previous class, we had seen about the concept of Kirchhoff's current law and concept of Kirchhoff's voltage law. In today's class, we will see about some of the problems associated with Kirchhoff's voltage law. So let us go into the problem now. So this is the first problem. For the given circuit in the figure, they are asking to find the voltage drop across the 2 ohm resistor, that is V1, and V2, that is the voltage drop across the 3 ohm resistor. Now this 2 ohm resistor, I am naming it as R1 branch, that is a resistive branch 1, and this 3 ohm resistor, I am naming it as resistor branch 2, resistive branch 2. So I am assuming the loop current, there is only one loop in the circuit, so I am considering the loop current direction in the clockwise, that is I. So now the current entering into the branch R1 is positive and current leaving the branch R1 is negative. Similarly, the current entering the branch R2, that is 3 ohm resistor, is positive and current leaving the branch R2 is negative. So now I have to apply the concept of the Kirchhoff's voltage law. So we know that the Kirchhoff's voltage law says algebraic sum of the voltage rise equal to the algebraic sum of the voltage drop in the closed circuit. So here there is only one rise because the conduction path moves from negative potential to the positive potential. I mean lowest potential to the highest potential. So there is only one rise, that is 20 volt voltage source. So 20 volt voltage source equal to the voltage drops. That means the conduction path moves from the positive potential to the negative potential, or the conduction path moves from the highest potential to the lowest potential. That is said to be voltage drops. So voltage drops are the R1, that is R1 into I plus R2 into I. Now I have to apply the values for R1 and R2. So 20 volt is equal to, the value of R1 is 2 into I plus the value of R3 is 3 into I. So 20 equal to 5I. Now I can find the value of I. I equal to 20 divided by 5, which is equal to 4 ampere. Now we have to find it out. What is the voltage drop across the 2 ohm resistor, that is V1 equal to the voltage drop across the 2 ohm resistor. So which is equal to 2 into I. Here it is represented by plus 2 into I. Why means? Because the conduction path direction and the given voltage polarity direction are same. So plus 2 into I, which is equal to 2 into 4, which is equal to 8 volt. Next, we have to find the voltage drop across the 3 ohm resistor, that is V2 equal to voltage drop across 3 ohm V, 3 ohm equal to, here the conduction path direction is from plus to minus, that is from highest polarity to the lowest polarity. But voltage drop is given from plus to minus. So both are in opposite direction. So we have to represent this branch voltage drop as minus 3 into I. This minus sign indicates that the opposite direction of the conduction path and the given path. So minus of 3 into I is 4 ampere, which is equal to minus 12 volt. So this is the value of V1 and V2. Next problem. This is the second problem. So second problem, they are asking to find what is V1 and V2 in the circuit. So V1 is a voltage drop across the R1 resistor. V2 is the voltage drop across the R2 resistor. Now I have to consider the current direction in the clockwise, that is I. So here in R1 branch, current entering into the 4 ohm resistor positive potential, current leaving from the R1 resistor is to be considered as negative potential. Similarly, in the 2 ohm resistor branch, that is R2 branch, the current entering into the 2 ohm resistor is positive and current leaving from the 2 ohm resistor is negative. So now I have to apply the KVL. So here they are the two voltage rises, that is here minus to plus, that is negative potential to the positive potential is one rise, that is 10 volt voltage source, and similarly from negative potential to the positive potential there is another voltage rise, that is 8 volt voltage source. So they are the two voltage rises. So 10 volt voltage rise and another one is a 8 volt voltage rise. So two voltage rises, 10 volt plus 8 volt is equal to drops, that is a drop across the R1 branches, that is R1 into I1, R1 into I, plus similarly drop across the R2 is R2 into I. Now substitute the value for R1 and R2. 18 equal to R1 is 4 in 4, so 4 into I. Similarly R2 is 2, so 2 into I. Now we can calculate for the value of I. So 18 equal to 6I. Now I equal to 3 ampere. So once if we know the I, we can calculate the voltage drop across the R1 and R2. So voltage drop across the R1 is V1, that is V4 ohm equal to 4 into I. Here conduction path and available voltage drop are same direction or with the same direction, so plus 4 into I. So 4 into I is 3, which is equal to 12 volt. Similarly, voltage drop across resistive branch 2 is R2 is V2 ohm, which is equal to, here the conduction path direction and the available polarity are in different direction. So we have to specify with negative sign. So minus 2 ohm, 2 into the current I, which is minus 2 into 3, which is equal to minus 6 volt. Therefore, V1 is the voltage drop across the 4 ohm resistor, which is equal to 12 volt, and V2 is the voltage drop across the 2 ohm resistor, which is equal to minus 6 volt. So this is how you have to solve this circuit by using the KVL equation. So to practice the problem, we will change the value for the branch element R1 and R2, and we may change the value for the source voltages also. So you have to use that particular value for your roll number what you have received, and you have to solve it and you have to submit it in the PDF format. I hope that you will be understood. Thank you.